Well, welcome everybody. So today's webinar we're going to be talking about is diagnosing production Akka.NET problems with OpenTelemetry. So we're going to be using a specific stack that we've been employing inside our test laboratory environment. And this is actually pretty close to what we use for monitoring some of our production systems that are running on Azure. So we use Seek, Grafana, and Prometheus on Azure for monitoring some of our products like SDK bin. We also use a little bit of application insights. I'll get into that in just a moment. The choice of telemetry platform that you want to use, we will touch on a little bit, but that's honestly not really the most important thing we're going to discuss here today. What we're going to get into is we're going to cover a little bit of OpenTelemetry basics. So I imagine everyone's got kind of different experience levels here. Now, I've given a number of OpenTelemetry and observability talks over the years, even before OpenTelemetry existed. I was talking about open tracing and some of the other standards that are built that were kind of built around the space. We're going to cover the OpenTelemetry basics. Now, one of the things that is really positive about .NET as an ecosystem is that we have OpenTelemetry baked into like our runtime and to popular frameworks like ASP.NET and so forth. So OpenTelemetry is becoming a lot more common. I've been selling Phobos, which is an OpenTelemetry implementation library for Akka.NET for several years, and that is not that has been met with a little bit of what's OpenTelemetry. So we're going to kind of cover that at the beginning of this talk here, but this is becoming less and less necessary. OpenTelemetry is getting adopted by more and more .NET businesses now, and that's a good thing. We're going to talk a little bit about local versus production telemetry stacks and why you should have both. Having OpenTelemetry running locally on your development machine is actually very valuable and is a really useful debugging technique you should be taking advantage of. So that's one of the things that we're going to touch on. Next, we're going to talk a bit about working with Phobos data. So Phobos, like I mentioned before, is our proprietary OpenTelemetry component for Akka.NET. It costs $4,000 a year. It's a site license for your company. The value you will get from it is well worth the price of admission. So a lot of people who are attending today are already Phobos customers. If you're not, you should go ahead and contact us and we'll give you some information at the end and consider using it for your org. We're going to talk about a couple of things Phobos does. Now, it's not just Phobos, it's also just a lot of OpenTelemetry instrumentation in general will help you do this, but I'm going to talk specifically about how Phobos does it. Noise control is going to be one of the most important things you do. Now, I have a background in analytics, mostly on kind of like the marketing side of things. And the impulse around this space is to try to gather as much data as possible because you don't know what questions you're going to need to ask later. That makes sense when the thing you're observing is human behavior, because you can't go back in time and make that customer do that thing again. When you're working with machine produced data, so machine to machine data, like what most OpenTelemetry stuff typically will capture, you need to be a little bit more careful about what you capture, because you can end up absolutely melting an Elasticsearch instance to total slag, or generating a giant DataDog bill or whatever. And not to mention the actual work your development team has to do to make sense of that telemetry data might be a lot harder if you capture way more information than what you actually need. So Phobos has a lot of good built-in defaults that are designed to protect you from getting exposed to a lot of useless noise in Akka.NET, but we're going to show you how to configure it to get exactly what you need and filter out what you don't. OpenTelemetry itself as a runtime also includes a lot of built-in filtration tools that will help reduce the amount of data that gets emitted. It'll also allow you to do things like sampling, and you can also even do some clever things like we actually have a custom OpenTelemetry processor built into Phobos that will allow you to compress all of the messaging around the cluster sharding system, where it basically strips out all of the built-in hops that cluster sharding uses itself. So you can do a lot with some of the built-in OpenTelemetry filtering tools right out of the box. Next, we're going to talk about custom metrics and traces. The built-in telemetry that you get out of like the HTTP client or the SQL client or out of Phobos, that is all very useful. But there's going to be contextually valuable things that only you, the owner of an application, can really judge for yourself as being valuable, or could be basically an important signal that kind of indicates the health or let's say well-being of your applications. We're going to talk a little bit about how to collect some of that data today as well. And then finally, we're going to talk a bit about crafting useful alerts. Let your telemetry system tell you when there's a problem. So we're going to go ahead and cover all this today. The total runtime for this presentation should be about an hour, and I'll make myself available to take some questions at the very end. But let's go ahead and dive in. By the way, if you have a question about anything I'm doing while I'm going here, just use the ask a question button in GoToWebinar. I'll try to review all of those at the very end. So OpenTelemetry at a glance, what is it? It is a unified vendor-neutral observability and monitoring standard, and it's implemented across pretty much every major platform and runtime. I mean, I think it's available for like JavaScript and C, in addition to, let's say, .NET and Go and Java and all that stuff. So it's pretty ubiquitous at this point, and it's getting more and more so all the time. It covers logging, metrics, tracing. It can work locally, so you do not need a DataDog or a Dynatrace license to get useful data out of this. You can go ahead and fire up. In fact, we're actually going to see an example of a local telemetry stack using Docker Compose, and this can kind of give you all of the benefits right there on your local development environment. So that's one of the things that this can do. All major APM vendors are basically involved and on board at this point. There might be some that aren't really included, but let's say, for instance, Azure or Google Cloud or AWS, DataDog, Dynatrace, New Relic, Elastic, and even open source projects like Prometheus, Jaeger, and Zipkin. They all support the OpenTelemetry standard. So you can basically bring your telemetry to whatever vendor you want for actually doing your processing, aggregation, alerting, etc. It doesn't really matter. OpenTelemetry is mostly designed to benefit framework authors and runtime authors like the .NET team or us here at Petabridge, as it gives us kind of a unified way of being able to describe metrics or activity sources for tracing, or a standard way of being able to export and aggregate logs. That's kind of what this is really aimed at doing, is making it possible for us to plug important signals from our frameworks and libraries into your view of how well your application is performing at any given time. On top of that, the other thing that it kind of does to benefit developers is that the actual instrumentation code that OpenTelemetry uses is standard regardless of where you export your data. One of the problems that we used to run into with, let's say, the open tracing standard is that I might have a really fast experience doing tracing with, let's say, Jaeger or Zipkin, but when I start using application insights, all of a sudden my application slows down significantly. And that's because the way traces are being computed could change quite a bit in those libraries. That's no longer the case here. OpenTelemetry is very performant. It's used at really, really large scales now. So it's basically suitable for any sized workload. It truly is kind of a one size fits all sort of paradigm here. Now, one of the things that OpenTelemetry supports out of the box in .NET is configuration as code. Essentially, we can just tap into the iService collection the same way you configure a ASP.NET or a headless Windows service. You can go ahead and tap into this and just say add OpenTelemetry, and then configure all the different little OpenTelemetry settings here. So the first thing we need to add is a resource. That's what this is right here. It describes the topology of what's being observed. So it includes things like your service name, the instance of your service. So that would be like your host name. In fact, this might be a case where pulling out some code might be the way to go here. This is some of our Phobos data. And if I zoom in a little bit right here, you can see here, this is our resource data from OpenTelemetry. So this includes the namespace. In this case, this is the Kubernetes namespace I'm running inside of. But if I have, let's say, an environment, let's say I'm deploying onto bare metal, and I have some virtual machines or some bare metal computers that are part of my QA setup. Some might be part of my user acceptance testing environment. Some might be part of my production environment. The namespace might be what you use to indicate that using your resource detector. Next, we have our service name. So if you have, let's say, a service-oriented architecture, you'd want to use the service name to distinguish the different services that communicate with each other. In Akka.NET parlance, you might want to use maybe the role of your Akka.NET cluster as your service name here. And then finally, we have the service instance. This basically describes, like, if I have 3 different instances of my draw together service, which one processed this message. So this kind of indicates which specific process was responsible for producing this trace. And then also you can include some optional stuff down here. Like I always include the assembly version as my way of versioning which version of my service produced this on here. So this is really useful if you're taking a look at like what happened during your service when it was being, what happened to your service during a rolling update. That version information can be really useful for indicating that. Next, we have metrics. Metrics basically are our way of sort of numerically describing what happened inside your applications. This includes common metric data types such as counters, gauges, and histograms. So for instance, Phobos will go ahead and expose some counters for keeping track of things like the number of messages processed by actor type and message type. That's something that Phobos instrumentation will grab for you. Whereas the HTTP client instrumentation will help you measure the number of HTTP requests, which destination they went to, which response code they came back, and it'll also produce things like histograms of how long, the histogram might have a distribution of response codes and also latencies potentially. So that's what metrics are there for. They're there to help you quantify the performance of your application. And then finally, we have tracing. Tracing is used to describe the dynamic behavior of your application. What happened in the course of trying to fulfill this end user's request. And so tracing is usually the most kind of expensive part here. And then finally, we have the exporter. The exporter basically describes where metrics, traces, and logs are sent for processing. So in this case, we're using the OpenTelemetry line protocol. This is kind of the built-in agent that OpenTelemetry ships either as a standalone process or they might ship it as a Docker container. And you basically can configure the OpenTelemetry line exporter to batch metrics together and then export them to a bunch of different destinations. We're going to see an example of that in just a moment. But this is basically what a sort of your normal sort of OpenTelemetry pipeline looks like. Now, because logging is kind of treated as a separate concern from tracing and metrics, and this is due to the way .NET does it, not to the way OpenTelemetry does it, we have to configure our logging pipeline basically to also explicitly use OpenTelemetry as well. So this is using the Microsoft.extensions.logging config right here. And what we're going to do is basically create our resource definition again. So we're going to use the exact same code we had before. So we're using an environment variable detector. We're using the telemetry SDK. And then I have a little custom component I wrote right here that's going to basically detect the service version using my foreground assembly version down here. And then finally, we add this builder.add OpenTelemetry. This is what's going to cause us to export to the OpenTelemetry exporter we configured earlier. So that's kind of this is a little foot gun that I ran into when I was setting up my OpenTelemetry pipeline. There's no need to explicitly add an exporter again if you already added the OTLP exporter on this previous slide, like we did it right here at the bottom. You don't need to do that a second time here. So you'll get actually a crash when that happens. So this is how you set up your OTEL logging configuration. Now, this is the OpenTelemetry line protocol collector. This is a little Docker agent that we're going to run. I'll show you some configuration code here. But the OTLP line protocol is basically a standardized wire format that describes metrics, traces, and logs. So most major OpenTelemetry enabled like APM systems like Dynatrace or DataDog, they can actually natively accept this, where you can, usually they'll expose an endpoint or maybe they'll expose an agent that you can work with locally that'll be able to accept this wire format and process them. So it's kind of the lingua franca for being able to work with OpenTelemetry. But OpenTelemetry also basically exposes its own collector agent that is a free open source component that you can configure using this like YAML file right here to basically say, I want to go ahead and gather logs, traces, and metrics, and then I want to route them to these destinations. So I'm going to actually link to a open source repository produced by Stephen Cleary, where he sets all this stuff up for you on a local environment. This is the version that we actually run in our test laboratory. So you'll see, for instance, if I grab my pen right here, we're using like a real domain name. This is like a local DNS name that hosts our Jaeger, our Seek, and our Aspire instances. So this is kind of like the slight difference between the one I'm going to show you and the one that we're using is that we actually are using a real network. We're not running everything on localhost. And then down here, you can go ahead and see these are our different export pipelines that the collector runs. So we're going to export all of our traces to Jaeger, Zipkin, Seek, and Aspire. All of our metrics are going to go to Prometheus and Aspire, and then all of our logs are going to go to Seek and Aspire as well. So the whole purpose of having this little collector sidecar is basically to make it feasible to go ahead and share your metrics and traces with a whole bunch of different APM systems you might want to connect to without needing to stick all of that garbage inside your C# and .NET applications or your F# applications as well. You can kind of outsource all of that to this little sidecar right here. And in fact, let me go ahead and pause sharing my screen real quick. I'm just going to dig up a Sublime text instance here. Let's see. Yep, this will work. Okay. Just to kind of show you a little bit about how we do this inside our applications right here. Let's see. I think this is good. Let me go ahead and share that. All right, so this is running inside our test lab environment. I'm not worried about anyone seeing our SQL password right here. This is a garbage database that doesn't do anything. And on top of that, it all runs basically inside our VPN protected environment. But the way we do things with OpenTelemetry, in fact, you know what? I need to grab one more little file here. Let me grab this. Let's see. This is in our Kubernetes folder, OpenTelemetry config. Here we go. This is how we actually roll out the OpenTelemetry collector inside. We have two different Kubernetes clusters that use OpenTelemetry collectors for being able to transmit data to our self-hosted OpenTelemetry APM system. So this is that config map that has that YAML file we were just looking at right here. So this is all pretty much the same stuff you saw before. One of the things that I added after I prepared that slide is we're actually going to decorate all of our metrics and traces with a custom attribute, which is going to be, in this case, I changed this value depending on what Kubernetes cluster we're deploying into, but this helps me differentiate which cluster this particular piece of data came from. So we can go ahead and configure that. I can also configure batching. This kind of reduces some of the network strain, particularly for metrics on some of our instances. All of our telemetry infrastructure is running on a Raspberry Pi unit, so it's able to handle hundreds of thousands of events per minute. So it's able to handle quite a lot of data. But we do add a little bit of batch processing to our OpenTelemetry collector endpoint just to kind of reduce some of that I/O overhead. And I deploy everything as a daemon set right here. This is a Kubernetes specific construct, but what this means is if I have 3 different Raspberry Pi instances that form my ARM64 cluster, each one of them is going to run a local copy of this agent. And then my application that I have right here, which is what I was showing earlier, I'm going to specify this is one of the OpenTelemetry environment variables you can use to kind of configure your service. So I'm configuring my service name. I'm configuring some of my resource attributes, namely my service namespace and my service instance right here. This is all part of the documented OpenTelemetry spec. And then this is the most important one, my OTLP exporter endpoint. I'm grabbing my node IP address from here. And I am basically saying I want to use the gRPC endpoint that exposes. That's what my application is going to ship all of its metrics to. This allows me to kind of federate a lot of my processing when I'm producing a lot of metrics, that each of my individual machines is going to pre-aggregate metrics, traces, and logs. I can even add things like filtering or sampling to my collector endpoint if I want to. It's going to do all that work locally before it exports stuff to my shared infrastructure that's going to be doing all my processing. This kind of helps reduce compute costs that's happening inside your APM cluster, and will also help you if you're using a production system like DataDog. This will also help you lower your bill as well, because you're basically doing things like filtering and stuff here. So that might reduce the amount of, let's say, API uploads or the amount of events you produce, which can be billable events depending on which system you use. So this brings up the question of local versus production telemetry stacks. And as you can see with my little comment here, no, you don't need DataDog everywhere. We have a lot of customers at Petabridge that use DataDog, Elastic, Dynatrace, Honeycomb, New Relic, all sorts of different cloud-hosted APM platforms. For local telemetry, I highly recommend Stephen Cleary's local telemetry stack, and I think we'll update our email that's going to get sent to all the attendees who registered today to include a link to this. This is perfect. Let's see, I think I just opened it in my browser somewhere. Let me see if I can pull that up. Maybe not. Let me go ahead and grab my PowerPoint again. That does not want to open. There we go. Got it. So Stephen Cleary, who you've probably definitely read some of his really fantastic blog posts and how async and await work in .NET at some point, he basically just put together a really handy Docker Compose stack that runs pretty much every open source open telemetry component out there. So Seek, which is my personal favorite, we're going to use this one a lot for processing logs and traces. Jaeger and Zipkin, which I don't really use anymore, but they're handy as well. Grafana, which is fantastic for processing metrics. They use Prometheus as the underlying data store for that. And then .NET Aspire, which can be useful for kind of sandboxing some of your metrics. I don't really recommend using Aspire at large scale, just because I think it has a lot of trouble in a resource. Let's say it's basically very resource intensive for a querying interface that isn't that powerful, basically. What is useful about Aspire, though, is if you want to make sure that your telemetry system is actually working, the metrics log and trace explorer works really well. And if you're doing this local development where you as an individual developer are trying to see if things light up and beep on your local system, .NET Aspire is actually fantastic for that use case. It's really good for being able to just make sure that, I fired up my Akadana application, I ran some requests through it, I want to make sure everything came out the other side. Aspire can help you with that. But if you're trying to actually do, let's say, shared environment monitoring, Aspire is probably not going to be the right tool for that job. But for local development, it works great. You want to get into the rhythm of using OpenTelemetry in your local debugging workflow, particularly if you're working with a lot of asynchronous or distributed systems. This will give you a lot of visibility into important key events that are happening behind the scenes. So that's something that I would strongly recommend that developers start getting in the habit of. Stephen Cleary's local telemetry stack will help you do that using the and by the way, this also runs an OpenTelemetry collector on your local host inside of it. I actually have this running on my machine right now, and I also have a stripped version of it running inside our test lab. Let's see, I kind of covered all that. Now for production telemetry stacks, it's probably best to go with cloud hosted. And the reason being is that telemetry tends to be very data intensive. So you do not want to be in the business of having to worry about running out of disk space or saturating your network. You can effectively outsource those problems to a cloud vendor like DataDog or Azure or Amazon or whoever. They all have OpenTelemetry compatible solutions that they will sell you. And yeah, like I said, the primary things that they help you with is they make it possible to manage all of the data ingestion. That's really quite useful. They also probably come with pretty good default dashboards for a lot of things as well. That being said, no matter what stack you pick, you're probably going to end up having to learn how to customize dashboards and alerts on there. That just kind of comes with the territory. So you're going to eventually just need to learn how to do that. But it gives you a lot out of the box. It also makes it easier to kind of share things amongst your team potentially. Now, the thing you want to be really careful with is cardinality and data volume. Cardinality refers to uniqueness. So for instance, one of the things we do not do in Phobos is we will not tag metrics with the unique actor path. The reason being is that you can have potentially millions of those running inside a system. DataDog, for instance, will charge you, or at least they used to, based off the number of unique keys and unique values for those keys in your metric, because those all represent aggregation points in there. So if you did something like include your actor path in your metrics, you could potentially end up with a bill that was tens of thousands of dollars if you produced even a relatively small volume of data. We've seen that happen before. So that's one thing you want to be careful with. Data volume is also potentially another set of billable events you might need to worry about. Now, if you're working for a really large company, we've got some customers that spend $500,000 a month on Dynatrace and Splunk licenses. They probably do not care very much about their data volume overall, just because it's kind of a drop in the bucket for a business that big. But if you're a smaller company like us, or you're someone operating off of, let's say, a limited budget, this is something you'll want to keep an eye on. This is kind of the risk you run with using a cloud-hosted solution is their billing is all designed to be very elastic, and it's kind of a, I'm not trying to ding Datadog or anyone else here, but they basically nickel and dime you for every single dimension, every single type of point of aggregation, and based off the volume of data that you send. So you want to be a little careful about that. Phobos tries to account for this because Akka.NET is a noisy system relative to something like ASP.NET, and that's because Akka.NET kind of facilitates a lot of low latency, high frequency interactions between actors. If we're tracing and measuring all of these, that could potentially result in a lot of data points. Phobos has been designed over the years and refined to account for all this, and this is where the noise suppression we're going to be talking about kind of comes into play. So we're going to get into that in just a moment. OTEL filtering can help quite a bit with this. Doing things like sampling, you can go ahead and cut your bill down to 1/10 the size based off the volume of data by using, let's say, a sampler inside OpenTelemetry, for instance. That will not help you with cardinality problems, though, by the way. The filtering may not help you with that. That's something that you want to kind of think about from day one as you're implementing your own metrics potentially. Now, one thing I don't want to do is discourage people from exploring self-hosting when it comes to metrics. That is definitely still an option, and that can actually be very cost-effective. What you basically need to have are good data retention policies that allow you to go ahead and bound the amount of disk access you're using. So we do this inside our test lab. We have like 7-day data retention on Seek and I think 14-day data retention on Prometheus. And that helps keep our disk space relatively open. Although that being said, if when we were using our test lab much more heavily to uncover some bugs with our cluster sharding system a month ago, I did the math and we were going to fill up our disk if we kept those experiments continuously running within about 4 days, because we have only about a terabyte or so of like NVMe storage on that little Raspberry Pi instance. So we're going to need to upgrade to have a much larger data system so I don't have to worry about that problem again. Paying for a couple more hard drives on a machine like that is probably pretty cheap compared to paying an extra $7,000 a month on DataDog. But then again, your mileage may vary. Now let's take a look at actually looking at Akka.NET specific data signals using Phobos. So Phobos has been around since about 2018. We've got dozens of customers that use it in production. It is basically OpenTelemetry instrumentation that has been handcrafted for Akka.NET. It's designed to be very high performance. So we made a couple of blog posts last year about some of the major performance improvements that have gone into Phobos. So Phobos is about half as fast as vanilla Akka.NET. It used to be 10% as fast. So we've made it quite a bit better. So adding tracing in particular requires stringifying lots of bits of data. And so there's going to be some inevitable overhead that occurs as a result of that. Even doing things like adding OpenTelemetry metrics can add a bit of overhead as well. But we've been very good about refining Phobos to be as fast as possible. We have a lot of techniques we use for doing things like, and I think I have a YouTube video on this, deferred allocation is one of the techniques we use, where traces don't get fully stringified until they hit the export pipeline. By that point, your actor already finished processing the message several seconds ago, usually. So we're pretty good about controlling that. Phobos is really good at automatically capturing useful data, such as the messages your actors are processing, actor starts, actor crashes, actor stops. We're also really good at capturing things like ask operations and being able to trace how long those took and whether they completed successfully. There's no instrumentation code that's required out of the box by users. You just install and configure Phobos and it'll just work out of the gate. It's also really good at suppressing noise automatically. A couple of examples of that. Messages that are run on a timer. So using, let's say, a scheduler or the iWithTimers interface on your actor, we do not trace those by default because typically those tend to be low value signals. You can always turn tracing on for that if you want to, but by default, we don't. To boot, we also don't capture metrics or traces from the built-in system actors in Akka.NET by default, but that is configurable. You can turn that on if needed. And then finally, it works like any other OpenTelemetry library. It automatically correlates Akka.NET activity with non-Akka activity. So if you have, let's say, a web request that comes in that results in sending an ask operation to an actor, and that actor does some stuff, which eventually results in an entity framework query, you'll see that end-to-end inside your application. It costs $4,000 per year per organization. It comes with support. We don't care how many developers you use it or how many projects you use it in or how many cores you're running on. None of that matters. It's just a flat fee. Well worth it, in my opinion, for the amount of time and trouble it will save you. So what data does Phobos capture automatically? What can we use as the basis for trying to monitor some of our Akadana applications? I'm going to show some dashboards in just a second, but I'm going to kind of talk a bit about what it does. For Akadana cluster, we keep track of the number of nodes by status and how reachable they are. For Akadana cluster sharding, we keep track of shard and entity allocations by region and by address. So we can see the number of nodes that have shards allocated on them, and also how many entities are allocated to those nodes. This is really useful for being able to observe things like shard rebalancing, for instance. In core Akka.NET, we keep track of actor starts and stops and the current number of alive actors by type and by address. Processed messages by actor and type and by message type, as well as by address. These are all low cardinality fields, so that meaning these values repeat quite a bit. That keeps them cheap. We also keep track of latency for message processing. So how many milliseconds on average did this message and this actor type take? We also keep track of log rates by level, address, and exception types. We also will log things like number of unhandled or dead letters as well. We keep track of that. And then actor crashes and restarts by type is also very useful as well. And so let's take a look at some dashboards for Akka.NET metrics here. Let me go ahead and reload my screen here. All right, here we go. So let's see, this is over the last 6 hours. You can see that I did a rolling update, maybe, looks like I did a couple of rolling updates over the past, from like when I got into the office this morning to when I had my first meeting. I think I did 2 updates here. That's what you can see, maybe 3 updates. That's what you can see on these little charts here. So we can see that we've got a total of 3 nodes. We've got no unreachable nodes right now. We can kind of see what's happened in our cluster. I can take a look at our cluster logging activity and see that we've logged, let's see, if I go to the last 30 minutes, we've had a couple of warning messages. Let me change this real quick to an I rate rather than a constant rate. And we can see that we've had a couple of warning and info messages pop up periodically. So we'll take a look at that. I'll change that back to a regular rate. This is all using Prometheus data. We haven't really had any exceptions. So I'll take a look and see what that warning is. We haven't had any real exceptions, and I can take a look at our actor message processing rates here, and I can see that we're doing roughly, and it kind of rises and dips. We're doing roughly about 300 messages a second. On average, we're doing 174 messages a second. That's what that total actor throughput says. And let's see if we have any dead letters. We had a couple of unhandled messages over the past 30 minutes, but no dead letters. All right, so I can see that. I can go ahead and see that we have a roughly even distribution of actors with slightly more on Draw Together 1. By the way, this is the application that we're monitoring right here, is this Draw Together app. If I go to my home screen, hit reload, I can join one of these drawing sessions. Let me go and change my color here. This is my demo application that we used in our Blazor webinar back in May. And if you want to see a little bit more about this, you can go ahead and watch the YouTube video of that. And this code sample is also open source on the Petabridge GitHub repository. But basically, I'm just doing a little bit of drawing here, gauging a little bit of activity. Go ahead and make my cursor size a bit bigger. And I'll clear my screen. All right, all that metrics, that's all going through. And so you can actually see here a spike in actor activity as a result of me doing that. That's probably all of the different little sharded entity actors and some of the different local actors that facilitate the sync between clients occurring here. You can see my message rate just went up as well. You can see a little spike in messaging activity occur here. Let's go ahead and do something really fun. I'm going to go ahead and open 2 different browser windows. Do one there. And I'll go ahead and do another one. Do this a little side by side. So it's just me, the same user, but you can see I'm drawing one stroke here, and I'll go ahead and draw another brush stroke here. You can see this is being synced. These are 2 different, this is the same user, same logical user, but I'm connected on multiple tabs. And my Draw Together application is using Akka.NET to sync my view state between these different browser windows right there. So that's basically what the application is measuring, is doing for us. And if I go here and let's go to the last 5 minutes maybe, and I hit reload, you can go ahead and basically see an increase in sort of the trend of the messages here. You can see the number of actors going up as well. And you can see that there's basically been, if I go and maybe if I change this to a regular rate, that'll be easier to see, run queries. We can basically see more persistent actors starting up and doing replays and stuff like that there. And I can also take a look at my message volume. Now in this application, I'm logging and keeping track of all my system messages, the ones that are handled automatically by Akka.net's built-in actors. Normally I run with that off by default, but I can go ahead and see, for instance, my Akka.remote endpoint manager. That's this endpoint manager.send. These are the number of messages being written over the network by Akka.remote. That's what that is. All these other messages here are kind of like built-in distributed data or clustering messages that are occurring. I can kind of go and filter through this all right here. And I can see some of messages actually coming from my application down here if I want to. And then finally, I can take a look at my shard allocation data. I can see that I have a roughly even distribution of shards. But in terms of the entity actors that are alive, this corresponds to drawings that people are actively using. They're all allocated on my first and second node, and none are allocated on my third. That's kind of the basis for our application here. Now, if I don't do any more drawing, we'll see our message volume drop back off. And you'll go ahead and see the number of actors gradually decrease as some of those session actors for our drawing sessions shut themselves down after a period of inactivity. This is the built-in Akka.net dashboard for Prometheus and Grafana that we actually published to Grafana Cloud. It's also really easy to go and write some custom dashboards. If I go over the last, let's say, let's go to the last 6 hours. This is for my same application I'm looking at, and I can toggle between different apps here if I want. This is taking a look, this is like a custom dashboard I threw together last night. This is taking a look at Akka.persistence activity. Now, ironically enough, this draw together sample, I was really struggling with a bunch of Kubernetes-induced DNS resolution errors where draw together couldn't contact SQL Server, and this was causing a lot of recovery problems. I tried deploying that same buggy version of the software this morning, and wouldn't you know it, I couldn't reproduce the DNS error anymore. So if that's not demo syndrome, I don't know what is. But what you can see here on my dashboard, if I mouse over this kind of shows me the volume of, let's say, messages being written to Akka.persistence, and we can see a spike right here. This is my recent activity I was just engaging in. So you can kind of see that occurring right here. This doesn't look as impressive when you're looking at the much more granular view, but if I look kind of over the last 6 hours and extrapolate, that makes sense. I can also see the number of snapshots getting loaded down here. This kind of corresponds to actors starting up. I can also take a look at the number of replay messages. This and load snapshots all kind of correlate together. And then I can take a look at the number of messages getting deleted, or sorry, snapshots getting deleted. We can see a couple of them periodically, not very often. And over here on the right, this chart, if I took a look at the data, this chart is trying to look for all of the angry messages that can come from Akka.persistence. So Akka.persistence save snapshot failure, delete snapshot failure, delete messages failure, replay messages failure, all that good stuff. None of those are currently being observed inside the application right now because Akka.persistence is working pretty well. But this is like an example of like a custom dashboard I threw together in about 10 minutes last night that will let me kind of use Phobos data to observe how well my application is actually performing from a persistence perspective. So Phobos captures a lot of data, and the default dashboard is really useful, but it's also quite easy to go ahead and write your own custom dashboards as well. The way we go and configure Phobos inside this application is I call this is using Akka hosting. I call configure Akka right here. This is the little custom extension method that I wrote. And this is the real add Akka method down here. I have another little extension method I wrote called add configure Akka telemetry, where I'm passing in some custom Phobos settings that I baked into my Microsoft.extensions.configuration object. And then I also have a trace filter, which we'll talk about in a moment. And I basically am specifying, do I want to monitor system actors or user actors, or do I want to monitor both, or do I want to have monitoring disabled? Ditto for tracing. By the way, this bit of code right here, some custom stuff we wrote for our test lab. I actually like using it so much that we're going to incorporate it into the real Phobos code base next week when we do our next release. So this is basically how we wire up Phobos here. I just call on the Akka configuration builder with Phobos. This is an extension method that the Phobos, let me go and open this up, that the Phobos.hosting package gives you. You have to add a custom NuGet package feed that we provide you with after you buy Phobos. That's where that package comes from. We go ahead and we just basically register with Phobos here, and then we specify, are we running Phobos as just a single process using just Akka.remote, or are we using Akka.cluster? This is going to inject the Phobos telemetry into all of our actors, and it's still highly configurable. So we can still basically do things like disable, Phobos metrics for system actors if we want to. So that's all built in there. But this is what actually creates all the telemetry. So you don't have to write any code yourself to do it. This is all that you really need, is enable, basically just call with Phobos. You actually don't even need any of this code down here if you just want to use the Phobos defaults, and it would just work automatically out of the box. No OpenTelemetry code is required beyond that for Phobos to work. So that's basically how we have Phobos kind of set up and some of the dashboards that we built. Probably the more interesting thing that Phobos does than metrics, though, is probably tracing and logging. So what data does Phobos capture as part of its tracing? Well, probably the most important thing that we want to keep track of are the messages that we're sending and receiving. So Akka.message.receive is the name of the operation, and we pass in the message type here. This is how we keep track of messages that we're receiving inside Phobos. We also keep track of whenever there's an ask operation, we'll go ahead and trace that using the response type that we expect. So this tracks the end-to-end ask operation. This will tell you how long it took, whether it completed successfully, etc. We also keep track of actor starts and spawns. This will track the instantiation of an actor. We also keep track of actor crashes. This is really useful for being able to determine if something bad happened inside our system. And then we also keep track of unhandled messages and dead letters. If you're not familiar with the difference between these two, a dead letter means that message got sent to an actor that either shut down or no longer exists. An unhandled message is almost always a programming error. This means that you sent the message to the actor, but the actor did not handle it inside any of its receive handlers. Therefore, you probably have a programming error. You should have handled that message. So either you sent it to the wrong place or the actor was not programmed correctly. And then finally, we also do things like automatically append all of the logs that Akka.net captures using the logging adapter. Those automatically get appended to any active traces when we're basically processing a message inside an actor. So you get that additional context added to each of these different messages you're processing. Let's take a look real quick at what we're using to aggregate this tracing data. This is Seek right here. Let me go and click to the front. Seek is built by the same developers that make Serialog. So that their company is called DataLust, and it performs both log aggregation but also trace processing. And this will ship as part of that local stack GitHub repository that I mentioned earlier. So one of the things that's really useful about working with Seek is the way it works is through what they call signals. Signals are basically just little filters that you can go ahead and apply to the logs or traces that you're looking at, and you can chain these together to give you a really detailed view of how your application's working. And one of the things that I really like about Seek signals is that they're all indexed. Now, bear in mind, we're running Seek on a Raspberry Pi. I could not find a more low-powered computer unless I went to a junkyard somewhere. So this is about as low-powered as it gets. I can do things like filter all of the logs and traces by the Kubernetes namespace they're running in. So this right here, if I look at it, is looking at that OpenTelemetry namespace and is saying, get all the messages that belong to the draw together namespace. So this is that. And then I could say, let's look for all of the warnings that occurred in this namespace over the past day. And you'll see these are all logs right here that are being recorded by the Microsoft.extensions.logging implementation that we're using. And I've got that. All right, that looks good. What if we take a look at unhandled messages that occurred in this namespace? Let me go ahead and run this real quickly. And this should hopefully find some in the next couple of seconds here. Here we go. So I see a whole bunch of unhandled messages. And if we look at what this seek signal is doing, it's filtering by event type. This is using the operation name that's built into OpenTelemetry to find this data. So this is going to take another second. Sorry about that. And if I take a look at this, I can see some of the built-in properties that Phobos is adding. It's adding, in this case, so this is for an unhandled message. It's saying this is the actor that was supposed to handle this message. This is the type of message it was received, and here was the sender of that message. Interesting. So I can also do a search right here. Let me get rid of unhandled messages. This will just search for any Phobos operation that has this property, Akada actor.receive message type equals TCP listener.socket event. And I can see here a combination of messages that were successfully processed. So that's what this is, and some dead letters even right here. Now, this isn't really a big deal. This means that the socket was probably closed while there was still some pending data being written. And that's just kind of the nature of the beast. We use Akka.io for powering petabridge.command. That's where this is coming from. But if I want to look for a more interesting message type, such as I have a custom signal for this application right here. Let's see. Let's take a look for the entity coordinator starting. Oops, actually, that's not this namespace. Sorry about that. Let's take a look for the drawing session shard region. There we go. This is looking for any actors at this path. That's what this seek signal is doing. And I can go ahead and find right here all the different queries that this actor's received. And here we go. Here's an interesting one. Let me close that. This is one of our user-defined messages. Subscribe to drawing session. This is what happens when a local actor running on a client wants to subscribe to the source of truth for this diagram and sync that little client screen with the same data every other active user of this drawing session can see at any given time. So that's what this is for right here. So one thing I might do, just to go ahead and make this a little bit more interesting, is let me get rid of this value right here. So now we're going to look for all the different instances where this message has been received, and I can create a brand new signal for this right here. And we're going to say subscribe to drawing session. And I'm going to go ahead and save that. And that subscribe to drawing session is going to get grouped as a potential Akada actor.receive message type signal I can search for and seek. And if I want to take a look at this trace, let's go and find a slightly older trace, just so that way I know for sure it's been indexed. Let's do show up on screen here. Again, I probably need to upgrade the hardware we're running our tracing system on. Yeah, indexing takes a little longer when you're using a computer that costs less than $100, which a Raspberry Pi does. Let's try looking at this older trace, see if that comes through. In fact, also do a find on this trace operation right here while I'm at it. If I look at data ingestion, we're doing, about 4,500 events a minute. And if I go to storage, I can see that none of my data since about 9:30 this morning has been indexed. Okay, so I need to look just a little bit further back in time. Let's go down to, let's say, an operation from, I'll change my time window here. Let's go from 8:45 to 9:45. Let's find a trace in this window. Actually, we'll go ahead and do 9:15. No events matched. All right, let's go ahead and try 9:35. Let's do 8:15. Well, that's a little problematic. No data in that range. I guess I'll just have to hope that some of these older events do get indexed at some point here. And that's okay. I'll go ahead and do find on that. And we'll let that go ahead and run in the background here. But this is some of the data you can go ahead and get out of Phobos. Now, one thing I want to talk a little bit about are the generally useful signals you can get out of Phobos for understanding how your Akadata application is performing. And we're going to use this data when it comes to crafting alerts in a minute. Did the cluster form correctly? So how many unreachable nodes do we have? How many nodes are detected as up and down? Is the cluster healthy? What's our error rate look like via the number of logs? What does our actor crash rate look like? And then finally, is the application doing what it should? Do we have roughly the number of live actors by type that we would expect? If we're running a multiplayer video game on Akka.net and we know it's peak hours, are the number of player character actors connected to our system right now, does that look like the number that we would normally expect given our sort of historical average? And how many messages by type are being processed right now? Does the volume of message processing kind of coincide with what we would normally expect out of Phobos? Sorry, out of our Akadana application. And then we have our generally useful Phobos tracing signals. Are the number of specific errors, specific actors, and specific messages, do these all match up to basically what we kind of expect would happen? So in the case of, if I go back to my seek data here, and let me get rid of this. And let's see if this will go ahead and give me my histogram that I'm looking for. If not, no worries. I got some more tracing data we can take a look at in our next couple of slides. Yeah. Here we go. So I can see my data here. So I see that if I take a look at this trace, this is working in kind of reverse chronological order. And I think my search is complete. This message gets sent to, let's take a look here. So this message gets received by my sharding actor right here. This drawing session actor receives this subscription, and it is going to send back a subscribe acknowledge. I can see the content of the message being sent right here. And I can see that, by the way, this entity actor is running on draw together 0. This local actor who receives this message is running on draw together 1. So this is internetwork communication happening right here. And I can see that it receives this subscribe acknowledgement. And this means that we're going to begin receiving a pump of data that's going to allow me to sync this drawing. So that tells me that everything worked according to my plan. That's the type of thing you want to be able to tell using Phobos tracing signals. Now, you can also look for things like unhandled messages and dead letters. These might be indicative of programming errors or runtime problems. Akada-actor.ask duration is another useful thing. I was helping a customer yesterday investigate what we believe is a database problem where they had ask operations that were timing out after 10 seconds. And it turns out this is because Postgres was having some trouble completing all of their Akada persistence recoveries on time. So we were able to determine that using Phobos data. We can also keep track of actor starts and stops. This can be really useful if you're trying to validate that an actor with a particular address or particular type started during a workflow where you would expect that to normally occur. Now, a couple of little useful examples here. These are some types of queries that we can go ahead and run inside Seek to kind of understand, for instance, like what did the total volume of activity look like in my environment? And in fact, to make this copy and pasteable, I'm going to go ahead and quit out of normal presentation mode PowerPoint, and I'm going to copy this here. This is a Seek aggregation query is what this is. So I'm going to go up here. We're in the draw together namespace. I'm going to ask it to, if I go back to the slide, count the number of messages from the stream where the actor message type is not null and the actor type is not null, and then group these messages by actor type and message type. And then we're going to go ahead and count the number of times each of these appear. Let's go ahead and do this. We'll do this over the last hour. Keyword group was not expected. Let's take a look at this. Group by, let me go here. Well, it would help if I got my syntax right, wouldn't it? I think I just need that. There we go. That's going to work. So this will go ahead and total up all these values over the past hour. I can turn this into I guess I can't do that as a pie chart, but I can see here that the most messages that were processed inside my system were basically from this get shard state or replayed messages or get shard region state. This is all Akada persistence recovery basically that's happening here. This is probably Phobos querying the sharding system. And then finally, I can see that the fourth most requested message is the one I care about. Add point to connected stroke. This is my actual drawing happening on screen right here. So I can use tracing data to potentially paint this picture here. Now I can also get this data, by the way, out of my Phobos metrics if I want to. But the reason why it's useful doing this here is you could potentially get a little bit more detailed if you want to. For instance, I could go ahead and do things like say where actor type starts with Akka.cluster and filter this all the way down to just my clustered actors if I want to. That's data that you might have a little bit, you can actually probably do that with Prometheus queries, but you might have a lot of trouble doing that on other platforms like DataDog potentially. I'm not saying you would, but I'm just saying it's something that I know for certain you can do with a tracing system. Doing that with metrics processing might be a little more difficult. So that's something that our tracing system will let us do. We can also do something much more specific if we want to, such as keeping track of the shard handoffs by node. This is a query that I use to debug that horrible cluster sharding bug that we mentioned in our last YouTube video. So actually, you know what? This is not going to find anything. Let me go back to the last 7 days. And that might actually take a little bit of time to go ahead and process. But this will tell us how many nodes processed a shard handoff. And I'll go ahead and let that run in the background if it completes it all. If it completes it all, that is, given our poor little Raspberry Pi's resource constraints. But these are some of the types of queries you can go ahead and do using the tracing system. Now, a couple of things I want to talk about before we get into talking a bit about alerts is Phobos noise control. This right here is a trace filter that I have built into this Draw Together application. And the idea behind this is trying to balance signal versus noise. This is what will make your tracing system cost effective from a dollars and cents standpoint, but it's also what will help make sure your developers don't waste time having to dig through the weeds. It'll also prevent things like our little Raspberry Pi instance from being overloaded with useless data potentially. Trace filters are probably the most comprehensive solution inside Phobos. It's basically just a little switch expression that determines, based on the type and content of this message potentially, should we trace this? So in this case, my trace filter is saying if we're getting a cluster sharding or cluster singleton message, trace those. That was to help me troubleshoot that DNS issue we were having earlier. But otherwise, I only want to trace messages if it implements my iWithdrawing session interface. This is kind of like the interface I use to identify the different entity, the drawing session entities we're working with. Or if we're already inside of a trace, then I want to trace this message. That way I don't end up breaking the chain of continuity that way. You can also use props or HOCON. There's a documentation on the Phobos website that explains this to disable or enable metrics on select actors or even the entire hierarchy if you want to. But probably if you want to go down this road, probably a better route than doing this is to do what I'm going to show you on the next slide, which is, let me grab this right here. You can go ahead and use these two interfaces, the I never instrumented. Well, actually, there's 3 interfaces here, but you can go ahead and decorate interfaces or messages or actor types with these interfaces here, where you basically say, I never trace, never record traces for this actor. I never monitor, never record metrics for this actor, or I never instrumented, don't do traces or metrics. Phobos will respect this when it sees it on a message or on a actor type, and will go ahead and implement that programming accordingly. So for instance, Phobos has some internal actors that do things like keep track of the number of nodes inside the cluster. We don't want that actor tracing itself because that would end up creating like a recursive loop of activity that would end up inflating a whole bunch of noise into your telemetry stream. So we use these interfaces inside those actors where we know we never want to monitor them. You can also do this inside some of your own messages or message types if you want. This works regardless of how you set your trace filter, by the way. As soon as a message gets decorated with I never instrumented, Phobos is never going to record that under any circumstances. Now, that's kind of the Phobos filtering side of things. The next thing I kind of want to talk a bit about is some of OpenTelemetry's built-in filtering. OpenTelemetry gives you the ability to do things like filter out metrics you don't want or potentially sample them if need be. So sampling is not really something you need to do for metrics. In this case, what we're going to do is add a view on our metrics thing here for all of this is all the latency traffic that we record. This is kind of one of our heavier duty metric types. You can add a view for akka.messages.latency. This is kind of the wildcard namespace for all these metric types here. And just say we want to drop those metrics. And in fact, I've got that configured. If I go back to my program.cs and I go to my draw together OTEL, I have that configured right here. I could also do things like, well, I guess drop is sort of the only real configuration it supports for that. I thought it might have supported sampling, but I guess not. So I'm able to go ahead and remove that particular metric from our emission stream here. And the OpenTelemetry exporter is what will do that. Finally, I can also set a trace ID ratio-based sampler to only record 10% of all traces. This is going to cut down on the total amount of traffic that OpenTelemetry ships to your collector by 10%. Sorry, it's going to reduce it by 90%. Only 10% will get kept. And the way this is working is based off of the trace ID. So all of the different operations in the same trace, all have the same trace ID. This means that it's not going to accidentally break your traces. It'll just exclude, either it's going to be all or nothing. Either everything in that trace is kept or none of it is kept. So this will kind of help maintain that data continuity that we care about. This is also useful for being able to go ahead and kind of reduce the total volume of data that we ship. Finally, I want to talk about custom OpenTelemetry metrics. It is very, very useful to write and author your own traces and metrics. This is an example from inside our test laboratory. This is the sample that we used for being able to find that horrible cluster sharding bug that we made that YouTube video about. So we had a piece of custom telemetry we built called a duplicate detector. This is what helped us detect the split brain whenever it occurred inside our reproduction sample. We created a custom meter and a custom activity source. Meters are where metrics come from. Activity sources are where traces come from. This is all part of the system.diagnostics namespace in .NET is where you get this. So the system.diagnostics.activity, that's where the activity source comes from. And then I don't remember the full namespace for metrics. I think it's just system.diagnostics. That's where basically this data source kind of comes from. I like to declare both of them as static singletons and then just reference them elsewhere. Now, technically, these are disposable resources, but usually you're going to be using these throughout the entire life cycle of your application. So disposing them never really happens. Therefore, it's not really important to go ahead and do that, in my opinion. Logs will normally come from your Microsoft extensions.logging. Serial log can also go ahead and do OpenTelemetry export as well. So all of that data is going to kind of naturally come from those sources. It's really tracing and metrics or where we have to do something special. So in this case, I've declared my meter as a duplicate detector using this constant string here, and my activity source I've given the same name. I've also declared some constants for some of my events. These are the operation names we're going to use for activities, and some of my metric names right here, such as duplicates.tracked, and also duplicates.detected.duration, and also my unit of measure down here, which is the number of actors we found. So to actually do stuff with OpenTelemetry, we have to go and declare metric types we want to work with. So if I go and pull up, let's say I'll take a look at this code sample first. This is creating what's called an observable gauge. So I'm not going to go into all the detail on the different types of metrics OpenTelemetry ships, but an observable gauge is basically a value that gets sampled on a background thread periodically. And gauges are typically meant to measure, let's say, values that kind of fluctuate up and down on their own over time. Memory usage or CPU usage are good examples of things that people would measure with gauges. In this case, we're querying some state from inside this actor to figure out how many duplicates were found. And we're just returning a long integer is what we're returning, or actually I guess maybe a short integer in this case is what we're returning back. And that's going to get exposed to the OpenTelemetry exporter as a gauge type with this value. And this gauge will get sampled every 30 seconds or so, roughly. So that's a gauge. Other custom metric types, for instance, if I take a look at my draw together application, I have a problem I was trying to solve on Monday with this code sample is my emails for Microsoft.ASP.NET.Identity. This is the platform we're using for allowing people to log in and manage accounts here. I was not getting any of my password forget emails, and that was driving me insane. So I actually went ahead and I created my own custom metrics telemetry. And I did this after I made these slides in the PowerPoint here. But I have, for instance, an event for email.sent, and I have some metrics here for all this stuff. And one of the things that you'll see me do is every time we do an email sent, I'm going to create what's called a bound counter right here, the static read-only counter int. So I'm going to create a counter using this meter, and I'm going to pass in my event name, the number of emails sent, the unit, which is the number of emails, the description. This is all stuff that's going to show up in my Prometheus or DataDog or Dynatrace output someplace. And every time this method gets invoked, record email sent, I'm going to increment that counter by 1, and I'm going to pass in a tag. In this case, the tag is going to be the sender. Which implementation of my email sender sent this? It's either going to be the no-op sender or the mailgun sender, which is my real implementation. And then when I record my email activity, I call activity source.start activity right here. I'm going to start the span. That's going to go ahead and help me determine when this began. And then I'm also going to set some tags on here. I'm going to set the user's email, the user ID, and the sender. These tags are all searchable properties. When I was doing those seek queries a minute ago, if I pull up my slide here, all right, so this timed out, no surprise there. But if I go back to, let's see, my normal UI here, and take a look at this. These values that you're seeing right here, these are tags or attributes that we're adding to these spans. These can all be indexed and searched inside OpenTelemetry. So that makes it really useful for us to go and find these operations later. And by the way, you can actually go ahead and add additional tags to your Phobos telemetry too, if you want. That would require doing a little bit of programming. But if I go here and let's find this actor. I can go ahead and do this context. Get instrumentation. To see, do I? Oh, you know what? I don't even have the Phobos library installed in here. That's why this won't work. Well, I guess another way I could do this is do var activity equals activity.current. And I could do activity.set tag. There we go. That's exactly what I was hoping for. This will grab the current Phobos trace. And the reason why we use a nullable property here is in the event that there is no trace, this value will be null. So you don't want this to throw a null reference exception if you do that. That's basically a way we can go ahead and append data to the existing Phobos trace if we want to. So that's doing things with OpenTelemetry metrics. And look, I had all these really nice annotations I could have used, but forgot. For doing things with traces, we just kind of talked through some of this here. We go ahead and we start an activity, and we can also pass in like the current parent activity, or we can do default. By default, when you call start activity, that's going to make this activity a child of whatever the current activity is. You don't need to do this necessarily on the end. And then you can go ahead and append all of your own custom tags to make this searchable if you want. You can also create what's called an event, which is what we're doing here. Events are like little sub items that can appear underneath your trace. So if I go back to seek and you see this message and waiting, these are events that Phobos appends to your Akka.NET activity. In this case, we're doing things like stringifying the content of your message so you can see exactly what this actor was doing at the time it received it. The last thing we'll focus in on, because I know we're running just a little bit over time here, is crafting useful alerts. So Phobos and OpenTelemetry generally expose two different potential sources for making alerts: metrics and traces. And we'll go ahead and lump logs under traces tentatively because it uses the same engine basically to do it. Metrics are designed to be fairly coarse-grained. Remember, low cardinality. It's kind of trying to give you a big picture overview of what's happening inside your system. So if you want to figure out if, let's say, your application is unavailable, metrics are probably going to be your tool for doing that. Hey, I normally expect to have a minimum of 3 nodes of this role type up inside my cluster, but now I only have 1. That would be something you can set a metric alert rule for. Now, metrics are, so here's the real idea behind metrics. Metrics can tell you when a big problem is happening, and they can do it fairly quickly. That's what makes them really useful, but they can't really explain to you why or where the error happened. That requires getting into a higher level of cardinality usually, and that's where the traces are going to come in. Traces are very fine-grained. It takes a tremendous amount of computing power to try to work backwards and detect a big problem with traces. These queries that my Raspberry Pi can do no problem with metrics are causing Seek to time out after 60 seconds. With it's basically essentially the same. The data is going to tell the same story, but this goes a very long, circuitous route to try to find it. Now, what makes traces and logs useful from an alerting perspective, though, is you can find really acute problems quite easily, and it can help the developer. You know, the most valuable resource in any of your organizations is your software developer's time. This can help that developer pinpoint exactly where something went wrong really quickly. So that's a really useful, let's say, trait of the system here. Now, if I go and pull up, let's say I'm going to pull up do a little high risk here. I'm going to go ahead and pull up my Slack channel where we have our test lab alerts right here. So this test lab alerts, so these are some Grafana alerts here. One of the things I did at 9 a.m. this morning is I went ahead and I fat fingered my database connection string. I intentionally gave it a connection string that resolved to a non-existent IP address. And as a result of this, Grafana was able to go ahead and detect that problem and fire an alert that I can go and dig into that, and I can see some errors on that dashboard that I set up earlier. That's all well and good. If I scroll up a bit higher, this is from last month when we were investigating that duplicate sharding issue. I can see a whole bunch of alerts being generated by Seek where we were able to find specific instances of where our reproduction experiment successfully reproduced a duplicate shard. And this will even tell me which shard was duplicated when this happens. That's why there's a big wall of spam here on this stuff. So if we take a look at our useful Okta.NET alerts, and I'll show you some examples of how I define those as kind of our closing bit here. For metrics, we can look at things like more than n downed or unreachable nodes. This will tell you if you have like cluster instability happening inside your system. Or you can take a look at and see if your error rate is greater than whatever your 30-minute average is, or maybe even better, higher than a hard value. So in our case, if we get more than, let's say, more than one like snapshot load failure or something like that, we go ahead and we triggered that Grafana alert that you saw in my Slack channel. That is exactly what those metrics are designed to help us do, help us identify a macro problem. For traces, we're looking for acute problems like the number of SQL timeout errors that occurred. So let's take a look at some examples of this real quick. I have, as far as our alert rules goes, looks like the only ones that I have, and we haven't had any in a couple of days, is we have this confirmed duplicate checks. When we're looking in our duplicate detector namespace, we're looking in logs that are recorded by actor path and by pod, and we're looking specifically for a signal called a duplicate check. And if this duplicate check is greater than 0, we're going to head and fire an alert every minute, roughly. And we're going to try to group all the incidences where this alert was found in 1-minute chunks. So this is a fairly useful expression here. If I wanted to create another alert, one thing I might do is use the draw together namespace, and we want to look for, I'll go ahead and do logs by actor path and pod. Sure, why not? I can go ahead and see all the different actors and pods that all appeared right here and the service versions. That's really useful. And I'm going to go ahead and say, I want to look for cases where we have let's do aka.actor.receive message type equals aka.persistence.load snapshot failure. This would indicate that something has gone seriously wrong with our database connection. And I'll load this real quick. Now, this probably won't find anything. Actually, maybe it will, given enough time. But what I'm going to do is I'm actually going to craft an alert out of this. And let's see, signal. Let's see, draw it together. Load snapshot failures. And if I find that this value is greater than 1, we're going to suppress this every couple of minutes. I'm going to have this write out an error to our Slack notification channel. And I'll save that. And this will now go ahead and start running on a clock behind the scenes, and it will leverage Seek's indexing to go ahead and do that. That's a fairly easy way to go and craft an alert in Seek. In Grafana, I have an alert rule. Let's see if I go to my dashboard here, alert rules. Let's take a look. Looks like I spelt my folder name wrong there. Whoops. Let's take a look at this one. I have an alert rule. This is, by the way, if you want to create a new alert, let's do that. That'd be a better way of doing this. Let's go to our dashboards. Let's go to our Phobos metrics by OTEL workload. let's look at this cluster right here, and let's do this. Let's go ahead and go to more, new alert rule. And it's going to go ahead and grab all the values from my dashboard right there. So we'll go to the active cluster size, idle CPU, x64. And we're going to say, okay, if my number of up members in the cluster, well, tell you what, we don't care about up members in the cluster. We care about downed members. That's what we care about. Let's say if the down members in the cluster is, and we want to go ahead and pull from series F, is above 1. Let's go ahead and do above 0. Why not? Preview. Guess I don't need that. Okay. We'll go ahead and do input F is above 0, preview. Then we're going to go ahead and stick this in our evaluation group. We'll go ahead and evaluate this once every minute. And I'm going to go ahead and have this fire into our Slack. And I can go ahead and set some timings on this if I want to. I won't customize that for now. We'll say idle CPU, x64, downed nodes, been detected. And you can actually reference some query variables and stuff in your message here if you want. I'm not going to spend a huge amount of time fixating on that. Has been detected in blah, blah. I can link to a runbook rule, which is like if we know this problem comes up, maybe you have like an internal JIRA document or God forbid SharePoint where you go ahead and document how to handle this. You can actually include a link to that here and that'll get included. There's an error in my rule. Where is that? Must be greater than the evaluation interval. All right, well, you know what? I'll just set that to 5 minutes. Save rule and exit. All right, now that's defined. So in the event that, if I go back to my alert rules here, if I go ahead and I trigger a downed node in here, I will go ahead and get a warning about that. And you can see our sort of evaluation periods here all the time. So that's the end of my presentation. I'll go ahead and take questions now. If you want to go ahead and write any in the box or use your raise your hand feature, and maybe I'll unmute your microphone so you can ask. But otherwise, for next steps, go ahead and check out phobos.petabridge.com. That's where you can learn a little bit more about what it does. You can see performance figures, some of the built-in dashboards, some of the tutorials are all there. You can also take a look. We have an OpenTelemetry playlist on our YouTube channel. You can look at that and use that data to basically figure out how to use distributed tracing and how to do some other stuff with Phobos and OpenTelemetry there. You can also go to Stephen Cleary's repository and try his local telemetry stack out. Highly recommend doing it. It'll be a great way to learn .NET Aspire if you haven't played with that at all. It won't help you with the deployment part of .NET Aspire, but the dashboard part it will help you with. But this is a great place to go and try out a whole bunch of local telemetry stacks and just kind of start getting in the habit of working with it. So thank you very much for your time, everybody. I'd love to take some questions now. No? Well, if you don't have any questions on the webinar, I'm sure we'll probably be reaching out to all of you with an email. And if you have any questions there, you can go ahead and ask them. Otherwise, you can always reach me on Discord. I'm Aaron on the web. We have a Phobos channel on there if you have any questions. Likewise, you can always email me at aaron@petabridge.com. Otherwise, thank you very much for your time, everybody. Really appreciate your attention. And yeah, let me know if there's anything we can do for you. Thank you very much.